Welcome back to week 12. So in this class, we'll move on to more advanced features, in particular, a basic definition of functions. We'll see how those are definitely easier and more flexible than in C++. And, uh, and then we'll go to various type of sequences, in particular lists, tuples, and dictionaries that are very flexible and useful. And so those are some of the data structure that make Python kind of more powerful. First of all, let's look at how we define function. This is very simple. So we have a definition, basically start with the def term, and then of course the indentation will indicate what's part of the function itself. We provide a list of arguments with their names, and then if needed, we'll have a return statement that returns a value. Notice that we don't have to express the type of the return, so that will be just determined by the what's assigned, and so that the type could be different depending on the outcome of the particular evaluation. And then we see how to call the function in different way, just the typical way of just giving a sequence of values. But then there is a more interesting way where we actually can give values associated with the name of the argument, in which case actually the order of the arguments provided is actually not important. So let's take a quick look at how this works in practice in Python. So I have code here to make it easier and faster. So let's say we have a function definition like this one. I'm just doing everything on the interpreter level. And so at this point, we have a compute volume that is actually a function. So if actually I evaluate the keyword compute volume, Python will tell you this is a function. So notice that it's different to evaluate compute volume than calling compute volume with some parameters. So we can call the function with a set of parameters, and that returns the product of the three elements. And so obviously we can try with different values, and so we will get the proper result. Can do 13 and so on. Now, interestingly, we can assign explicitly the value to the parameters, calling the name. Here you have in the definition, you have width, height, and depth. And so here when I call, I can say width equal 4, height 5, and depth 3. And in this case, basically the result is the same because the order is the same. But now we can change the order. And so here I can give depth, height, and width in different order, and the computation is the same, and the result it's what we would expect. So this Python gives some flexibility of how to do things, and so this will help in the way you call the function. It's kind of more based on the context of the application you're writing than being restricted by the syntax of the language. Now, moving on to the other topics, let's look at the first type of sequences, kind of simple and flexible, the lists. So lists are sequences of values. They don't have to be all at the same time. Here you see a string with 2 integers. They are described in square brackets, and they're just a sequence followed by commas. So here I can assign a list to a variable. So the value of the variable is the list itself. We can use the addressing operator with the square brackets to select one particular element, and we can also do it backward from the end. So the element of index -1 is the last one, and then -2 is the one before that. Or we can address a sub sequence in the list. The way you see here. So again, just to look at inside the code, kind of to get a more practical sense, we can have a list L. And so now L, the value of L is the sequence of values. So now L, sorry, let me do this. So now L with 0 is the first element, L with 1 is the second, and obviously as L with 2 is the third. So obviously you can see that if you go outside of the range, you try to address L with 3 and you get an error message. But you can also refer things kind of backward. So L -1 is the last element. So again, it's the values 2. L -2 is the previous one, and so on and so forth. L -3. And let's see. And of course, L -4, it goes out of the range because you do -1, -2, -3, and then you went too far. We can also address a subset of kind of a sub-range. And so L13. And so notice that the last index is excluded. So it's really 0 is skipped. Then you have 1 and 2. And then you can have a subset of the array itself. So we can look at then how to modify the list. And so we can add elements. So if you start from an empty list, here you can append an element at the end. So you have the append function, and then you get the value. You can append the string. You can do the sum of two lists. You see, this is not a value, but it's a list that contains just a value. And so similar to string, the addition operator is really the concatenation of the string, and then you can do things this way. Now, on the flip side, you can look at removing elements. And so different operators will do the job. So you can create a list of elements like this directly, 1, 2, 3, 2. And now there is a remove method. Notice that this is a method of the list itself. So it's being called by L.remove. So every list has a set of methods as if it was a C++ class. And then you say remove 2 really means scan through, remove this. The first element has value 2. So and this is a removal in place. So you do L remove 2. When people call it removal in place, it means the L itself is not creating a copy. L itself is being removed. As you can see, there used to be a 2 here in the middle, and that got removed. The delete function it tells you which element you're going to delete. So you have delete, and then refer to a particular element by index. And in this case, after the removal of the first 2 here, you remove the second one. And then the pop is remove the first element, but also return it. So it's useful when you have a queue or a stack, actually, then you can push and pop elements in a list to use it kind of in terms of that data structure. So let's see running things in practice. So we're looking at adding first. So let's say we start from an empty list L. So you see this is an L, and then we can start adding an element. So this add elements at the end of the list. As usual, you have to evaluate L to see what happens. Let's say I can add another element at the end, and 10 and 9. And then we can add kind of a string to the list, and so on. So now we can look at adding let's say actually make it 4 and 5. So concatenating two strings. So this was the first part, 10, 9, and X. And then 9.5, 4, and 5. So this becomes a single string. Here I'm deviating a little bit from what was on the slides. On the flip side, when we talk about removal, so we can take a list with a number of elements. And so here is the initial state. And now again, we can do the search and remove. So here we can do remove 2. And then notice that we could do it again. So you can also think about what would happen when we do this and there is no 2 in the list. Again, you get an error coming out that. So maybe let's go back to the initial value. I kind of remove this. We can just delete one element by its index. So actually, let's do this. First, look at who is L with 2. So is the element of L value here 3 before it was done after removal. And so now if I do deletion of that, actually let me show that I address that. The list is unchanged. Now I delete the element with that index, and now we have 3 is gone, and we have 1, 2, 2. If we want to remove the top of the list, so notice that here those operation would not return any value, but now if I do pop, I get a value return. So that is something I could assign to a variable. In fact, let me do this. Let's say new element. So new element equal pop, and so here we have element 2, and now the list reduced to just one element, and so on. So there is flexibility, and this allows to add things from the front, from the back, delete them. It makes the list kind of a fairly flexible data structure. So now tuples are instead of special cycle sequences that is not mutable. So and that give a way to Python to do things with a certain efficiency. They can be implicit, but generally speaking, it's a rigid version of a list. So list you can move and so on, things all over the place, and that you pay a price in terms of performance. On the flip side, a tuple, it's immutable. And so you can, for example, create a pair of objects. You can use it to create a list of arguments to pass to a function, or for example, to build a sequence of elements that you want to use in iteration for a loop. You can still refer to the object by index, but obviously there is not much else you can do than referring to the object, because the tuple itself is built to not be immutable. So let's create a simple one. Notice the syntax that I don't even need the parentheses. I can say pair, a string, and a number, and then there is no value returned, but then pair is assigned that particular value. And so now you can start addressing the elements. Pair with 0 is rage, and pair with 1 is 2011. And of course, you can also do ranges. In this case, it's very short, so there is no much to do with it. Remember, when you do a range, the last element is not included. So in this case, if we want the whole list in the whole tuple, sorry, you have to do 0 to 2 to get the index 0 and index 1. So let's move on to the last kind of more advanced data structure. This is with dictionaries. And basically, this allows to deal with the sequence of elements where you have a key that you use to search for things. So far, we addressed everything by their location, the first, the last, index 2, and so on. In a dictionary, instead, you have these pairs of key value so that you have a list of values, and then you can use the key to search for the actual value. And then you and so you see that you can add an entry if it's not present in the dictionary, or you can remove an element based on searching the entry and removing that. So here kind of generalize the idea of a list. And so instead of just using the location or the index of the element, then in some sense, this does not dictate what is the internal representation, but the indexing operator will use the key. And so where the key obviously is the first of each pair. So notice that, for example, here I do address dictionary world. Now this hello, the key hello has value world, so that does not matter. So this look for element of key world and then assign value hello. And then this gets added to the dictionary. If that was already existing, it will replace the value. So initially we had hello world year 2017. And then with this operation, we added the additional element world hello. And so those are different from each other. And then we can remove the one that was existing from the beginning, again, through the key. And then the dictionary gets a little bit shorter. So what we can do, obviously, we can do this type of management and adding and removing elements, but also a dictionary can be used to iterate across elements. So here it's a for loop where we have key and value. So you have two variables that get assigned at the same time, and you iterate across the items of the dictionary itself. And in this case, for example, this would be a loop where you print the values of all the elements in a particular dictionary. Or you can actually iterate through the keys and then print based on that. So now let's look at this in practice. Let's go back to the code. And so here we have our initial very simple dictionary. And so here we can look at, so dictionary is hello with value world and year with value 2017. So here we can actually, let's see, dictionary world return an error because world as a key does not exist. The keys are hello and year. So notice how interesting is that I cannot read the value, but I can do the assignment. So dictionary world assign hello actually works. In fact, now when I do dictionary world, I get value hello. And of course, I can look at the value of the entire dictionary. I get those three elements as the expected before. Now, removal of an element, as we look at that. So del delete dictionary hello. So just think about this, give a reference to these elements that will be removed. So hello has value world. So the first element should go. And that's what we have. And so we have shortened our dictionary to this point. Now, if we look at having the loop for printing the values, here you see I done a loop where key value, take all the elements, and those are all pairs. And then we do print. This is the syntax of printing the two values with a formatting. One value end up here and one here with a format string. And so key year value 2017, key world value hello. And notice that in principle, we're not guaranteed that this loop happen in a particular order. We just know that we go through all the elements of the array. We can have a simpler loop to just print the keys. So you see we go for key in dictionary. So instead of dictionary items, you just do dictionary. It implies that you go through the keys. And then we do the print statement is the key is the year and key is the world. And so this is kind of the basics of how to use dictionaries, how to use tuples, and how to use lists. And this gives a lot of flexibility in terms of what you can do in Python with this type of data structure. Thank you.